All right, so we are going to start with the bitwise operator, right? So bitwise operators. So these are operators. These are binary operators, right? So we can have the logical and or x or not left shift. So I'm going to declare two variables. X is 10 and y is 4. So in binary, this is, so I'm just going to do their binary equivalent. So this is going to be 1010, right? And this is going to be 0100. Now, how do I get to this? So in primary, we do 10 divided by 2, and the remainder is 0, right? The remainder is 5, remainder 0, so you keep 0. And then now you do 5 divide 2, which will be 1. So this is the first 0, and then now it will be 2, remainder will be 2, remainder 1, and this is the 1. Then now you're going to do 2 divide 2, and the answer will be 1, remainder 0, so this is a 0 that's remaining. And then now we're going to do 1 divide 2, which will be 1. It will be 0, remainder 1, right? Remainder 1, right? So we take the remainder for each case, right? So that's why we have that. And other people will do it differently by doing, if you want to go back, let's do 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2, or plus 0, right? 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 0 times 2 raised to the power 0. So this will give me 8 plus 0 plus 2 plus 0, which is 10. Okay, the same thing will be done for that down there. So print, that's just to remind you on how you can calculate that. So print x and y. So I expect this to give me 0. Why? I'm going to do the computations up here. So I'll just do it like this here. So let's look. So it's going to return where there is 1. If we have 1 up and 1 down, then it's going to return it. But if it is 0 0, it's going to return 0. So this one, the first one, here will return, the first one returns 0 because we have 1 and 0. The other one is 0 and 1, so it returns 0. 0 and 1 returns 0 and 0. So the output here will be 0. So let's see. Yes, which is good. Now the next one, which is I'm going to do print x or y. Now this is saying that we should have where we have 1, right. So this is going to give me a certain output of where we have 1 and 0 is going to be, yes, it's going to be a true if you have 1 and 0. So it's going to be a true also because we have 0 here, 1 here, we have 0 here, 1 here. So this one is also going to be a true, and here we have 0 0, so it's going to be a false, right? So this is going to give me, what is the answer here? This is 2 raised to the power 3. This is 2 raised to the power 3 plus 2 raised to the power 2 plus 2 raised to the power 1 plus 0. So this will be 8 plus 4 plus 2, which gives me 14. So we expect the answer there to be 14. Good. All right. Now we go to the next one, which is print x and the cap and y. Now, so the output there was 14. So now this one works in such a way that how do I really put that? Okay, so we're going to expect to have like where there is 1, where there's 1 is going to, if you have any or, right, x or, except where there is the same, right? So where there's the same, there's no answer, right? We don't put, we put 1 where there's the same. No, what am I saying? So here we're going to have wherever I see 1 is going to be, if we have true and false, the output is going to be true. Yes, I think that's the right word. If we have false and true, the output is going to be true. If we have false and true and false, the output is going to be true. And then we have false and false, the output is false. The same way, if you have true and true, the output is false. So basically this will give me again 14. What a coincidence. So if I run again, print, we have not, so not x. Now this will be the simplest way to get this is that you put a negative sign in front of whatever value of x is, and then you add 1. Bam, bam, bam. That should work. So that's how I always do it. So I just see it gives me negative 11, right? So like that. Then we do print. The next one is the shift. So this is going to be x. Let's go, okay, left shift of 1. Now how does this one works? So we're going to shift whatever x is one place, right? This is x, so I'm going to write it like this. I'll put 4 zeros in front because we're already at the end, right? And then what happened is that we're going to shift it one place to the left, which means that this one will come here, then this 0 comes to where this one is, and then this one comes to this. So it will be 0 0 0 1, right? So we have moved this one from this position to this position, and then now on the other hand, now we have 0 takes the first place, 1, and then 0 0. So if you compute this, you should have, what should we have? There is, we have 2 raised to the power 4, no, 5, no, 4, yes, 2 raised to the power 4 plus 0 plus 2 raised to the power 2 plus 0 plus 0. I think I've explained that before. Was 2 raised to the power, this should be 16 plus 4. So that gives me 20. Let's see. Oh, perfect. Okay. Now we have print. Okay, let me just do another example. So if we're going to shift 2 times, right? 2 like that. Oh, I think I should get this one. So this will be 0 0 0 0. Then we have 1 0 1 0. And this will be, we shifted 2 places. So this will be 0 0 1 0, then 1 0 0 0, right? This is supposed to give me 2 raised to the power 5. Be sure. 2 raised to the power 5 plus 0 plus 2 raised to the power 3 plus 2 raised to the power 2 plus 2 raised to the power 1 plus 2 raised to the power. So this should be, we had here 20. No, we had here 16. 16 times 2 is 32 plus 2 raised to the power 8. So this gives me 40. Right, this gives me 40. So let's check and see if we have 40. Okay, good. Yeah, I think we are getting it right. So now we're going to do the last one, print x up up. Now this is to the right now by 1. So we're going to shift to the right by 1. I think like that it's become very easy for you to understand. So if we're shifting to the right by 1, it means that we're going to have 0 0 0 0 for these four zeros, and then we're going to shift this by 1. So this one now will become 0 and then 1 0 1. Yes, and this is just 5, right? I think I've done this so many times. So this is 2 raised to the power 2, which is 4, and 2 raised to the power 0, which is 1, and this will just give me 5, right? So that's fine. So that is with binary bitwise operators. I think like that it's good. So we have membership operators, right? So for membership operators, what are we doing? We're just checking if we have in and not in. So I'm going to do a list of numbers, right? So I have 1 2 3, separated by comma, 1 2 3 4 5, and then now I can just do 1 in list, right? I can just do something like that. Yes, it tells me true, right, that 1 is found in the list, right? So I can also do let me put another mark down. So I can do 5 in list. No, so give me false, right? Oh, 5 is there. Okay, so let's go with 15. All right, I thought that 5 was not there. So it gives me false, right? So we can also do not in, right? So I can also do not in by checking if 15 is not in my list, right? So you see how Python is very easy, right? Python is very easy. It makes life so simple for you. And then we also have identity operators, where identity operators we can have is and is not. So the same thing I can do one thing, guys. Yes, let's do so I had this x is 10 and let's say y is 4 again. So I'm going to do x is y. So let me just do this. So it tells me that it's not the same, right? It's not the same, right? So if I do let me pass it in a print. So I like to write like that. It's not y, right? True, right? So let me also put this one in print, right? So yes, so it's false, right? And it's true. So x is not the same as y, right? So then now we have the last one, which is the ternary operator. So this one is a shorthand of the if else statement. So here you see me declaring two values, right? I declare two values, x is 1 and this x is 10 and y is 20. So I just want to get the max. So I say x max is equals to x if x is greater than y, else y. So if I run this, it gives me the max. So if I want to get the mean, right, I can do x if x is less than y. It means that y will be mean, else it is y that is the mean, right? So if I just do mean, or you can notice that so many times in Jupyter I'm just writing without putting the print, right? It works like that. Okay, so now this is it. So we have learned about operators. So now we're going to do a simple example where we're going to write a program, right? So I'm going to do a simple program that okay, so that asks the user to enter the length and width of a rectangle, and then we use that to calculate the area and perimeter of the rectangle. So without much I do, so I'm just going to calculate area and perimeter of a rectangle. Okay, so I'm going to declare x, or let's say length, to be, so we're going to accept user input, right? So I do input. So this is the first time that we're doing that. So enter the length, right? I should have done this in another video, because this is going to, there are many concepts that I'm going to explain here. So if I do print length, right, so it asks the user to enter something, right, and it prints it, right? So like that. So I can do the same for the width, right? I can do the same for the width, and just change here to be width and enter the width of your rectangle. So and now I can do enter width to give me the area, right? So he asked me, let me put 3.5, then I put 2.5 here. Now, but look at what happened, right? Look at what happened. That's what I wanted. Can't multiply sequence of known int of type string. Now, why they say that? Why they say that it is int of not of known int of type string. So let me remove this. Let me do type of length. Right? Look. Oh. So it tells me that it's a string. Jesus Christ, how can I enter a floating point number and it's a string? Okay, so right, what can we do now to convert it is as a string? So when users enter values, right, it's considered to be string when we use this input like this. So what I need to do is I can add a float here. That is typecasting that we saw sometime in other videos. So if you have not seen the video on typecasting, I'm going to link the video here, so you can go to typecasting and actually look at the video there. So now I can print this, and so if I do 3.5, 2.1, and it tells me that it's a float, which means that I can calculate the area now to be length star width, right? So I can just print here that area double dot comma area. The same thing, I want to do perimeter, so I'll do perimeter should be equals to 2 times the length plus the width. And then here I'm going to print out perimeter to be perimeter. So I just run this code. It asks me to enter 5.5, then the width is 2.3. So it gives me this for the area and that for the parameter. All right, so far so good. So I'm going to end this video here. But now before ending, I think I have, yeah, it's good. It's good. All right, so we end the video here, and we will see in our next video where we'll be talking about control flow.